So this mainly deals with function composition. Not only. But let's talk about function composition for a moment. Let's say we have a function, the square root of x squared minus 3x plus 5. I would like you to decompose this function into what we call inner and outer. That's what I torture my algebra students with this because of this topic. In other words, I'm given this function and I'm asked to evaluate for x equals 0. Which part of this do I start with? Remember, this is an operator, and this is a function inside. I must start with the function inside. I cannot take the square root. First, I have to see what's inside the square root, and then I apply the outside operator. So the inner function is this. When I'm done evaluating this for 0, for example, as an example, then I apply the square root as the outer function, the second function. So the inner will be x squared minus 3x plus 5, and the outer will be the square root of x. So here's the next question. We know about the function composition as f comp g of x, which is f is the outer and g of x is the inner. Inner, of course, which will be evaluated first, and outer, which will be evaluated second. When we want to differentiate something like this, when I have to differentiate f of g of x, like this one, we're going to work on this one in a minute, then, however, we differentiate the outer function first, f prime of g of x, and we multiply it by the inner function prime. Let's start with a simple example, and 2 minutes later we'll come back to that. So now let's say I want to differentiate x to the 4th power. And you can say there is no chain rule here. I agree, there isn't, although everything is a function composition. How will you differentiate this? To the? Good. I should have asked you to also call or continue with x prime, the inner function prime. This is the outer. Why? Because first I have to evaluate x, and then I have to apply the operator power 4. But the reason why we did not write this was because x prime is 1. That's the reason why we didn't have to write this. But now when I differentiate something like this, a function inside another function, that's a totally different situation. So when I differentiate the square root of x squared minus 3x plus 5, I have to first differentiate the outer function as if I only have x inside and nothing else. What is the derivative of the square root of x? We know that by heart by now. 1 over 2 the square root of x. But now I have to put this instead of x, all this. So this is 1 over 2 the square root of x squared minus 3x plus 5 times what I had here, and I didn't write it, the inner function prime. So let's put it in parentheses for everyone to see first. Prime. It's this that I omitted. Why? Because x prime is 1. But if I had anything else in here, I would have written times that function prime. So we're not done. We have one more step. And then I want to show you another example, and then we pick any problem you want from the book. So this is, when I differentiate x squared minus 3x plus 5, what do we get? Bring down the power. What do we get when we differentiate x squared? 2x. 2x. What do we get when we differentiate negative 3x? Very good. divided by 2 the square root x squared minus 3x plus 5. And this is the final form of the derivative of that. Before I let you free to choose anything you want, I would like us to look at one more example. Let's say we have x squared plus 5x minus 3 raised to the 10th power. And I want to differentiate this. Can anyone tell us which one is the inner function? Inner function that we evaluate first.
X squared plus 5x.
What is the outer function that we evaluate second?
10.
Good. So just imagine if I only had here x to the 10th power, what would you have written? 10 times x to the 9th times x prime. But how much is x prime? 1. But now I don't have x alone. I have an expression or a function, right? So this will be 10 times x squared plus 5x minus 3 to the
9.
Good. Multiplied by this prime. Can anyone differentiate x squared for us? Good. Can anyone differentiate 5x for us?
5.
Can anyone differentiate negative 3?
0.
That's it. So this is how we differentiate. Would you have, are you willing to raise this to the 10th power and differentiate it afterwards? No, we'll still find it here on Tuesday if you want to do that. And we don't need to do anything else. We don't need to distribute. This is it. So now we are free to choose anything you want from on page 163 to practice the chain rule. 163 from 1 through 44. Anything catches your eye. And then the last section is higher order derivatives. So for example, when we differentiate the distance, what do we get? What is the rate of change of distance with respect to time? How is it called? Velocity. That's the first derivative of distance. But if I want to continue differentiating the velocity, what will I get? The acceleration. That will be the second derivative of the distance. Okay, we're ready to practice this? Which one?
Can we do either number 15 or 16?
Yes, of course. Whatever it is, 16. 16. 7x to the third divided by 4 minus 9x to the 5th power. Good pick. So since we are given y, you can feel free, I don't have any problem if you change it into f of x, or we determine dy over dx. We should get used to both notations. This is useful for later. Okay, so that's the same thing. Okay, it's what type of function? Is it a product? Is it a quotient? It's a, yes, or rational or quotient. The denominator will be squared. When we square 4 minus 9x to the 5th and we square that, what do we get? What power? Okay, let's do this. X to the 5th, everything squared. I copy the base. What do I do with the exponents? Careful. Yes, we multiply them when we raise to a power. We add when we multiply. Right? Okay, so this becomes power 10. And now we have to be careful with the top. Again, I have a constant. It's a factor by itself. If I had here plus 5, I could have not separated the 7. But it's 7 times a function. It can wait for me outside. I don't want to bother with it. There is no point. It will just, the top will look a little bit more involving. Good, so I'm differentiating the top function and I get Very good. Times the denominator. Minus the top times the denominator prime. Now I have to use the chain rule. Oh, I don't want to forget about that problem with, what was that, 1 over 1 minus x or something? Okay, I want to do that. Now we can. Okay, so now I have to differentiate this. Remember the power rule. Exactly the same idea. I bring the power in front, I subtract 1 from the power, and I differentiate this. Ready? So we're differentiating, it's the same thing. Okay, we bring down 5. 4 minus 9x to the
4.
Very good. Times the inner function prime. How much is 4 prime?
0.
How much is negative 9x prime?
Negative 9.
Correct. Correct. So I have to put in parentheses. Negative 9 in here. And you can say, is this it? No. No, it isn't. We have to simplify it. Seven can wait. I will rewrite 3x squared with 4 minus 9x to the 5th. Then I have a negative 9 times 5, 45, with minus in front, so positive 45x cubed, 4 minus 9x to the 4th. Let me repeat what I just did for everyone to make sure everyone understands this. Okay. So I have a 5, I have a minus 1, I have a 5, and I have a negative 9. 45 with minus in front becomes positive. And then I copy x cubed, and I copy the parentheses. Now let's look at the top. When I torture my algebra students with this, they always ask, why? And here's why. So how many terms do we see here?
4. 2.
One product plus another product. I would like to factor out common factors. So this is the first term and this is the second term. And they have a lot in common. There's a 3 in common. There's a 3 and a 45. They have 3 in common. There is x squared and x cubed. X to which power? Awesome. And there is a 4 minus 9x to the 5th and a 4 minus 9x to the 4th. Which one is in common and what power? Of course, 4 minus 9x, but which power?
4.
Excellent. Please open brackets now. How many terms we have to have in here? Well, something coming from left over from the first term, and then plus, this plus, something coming or being left over from the second. Agreed?
Mm-hmm.
Perfect. So 3 is out, x squared is out, 4 of the 5 ones are out. So what is left?
4 minus 9.
Very good. Excellent. Now I reach the plus sign. I have to write plus. Okay. From 45, I took out the 3. What is left inside?
15.
Very good. 15 times 3 is 45. From x cubed, I took out 2 of those. How many x's are still left?
1.
Very good. So 15x for now. And then from 4 minus 9x to the 4th, I took all of them out. So if you want, you can write just times 1 or nothing. Look what I'm going to do next. And I hope you agree. Which I could have not done before. Now this is a factor. That's why I can simplify with another factor from the denominator. I had 10 of those, but I'm removing 4. So I'm left with 6. I also have to combine like terms inside brackets. And now I can multiply. So 21x squared, and can anyone give us what is left over? And then denominator to the 6th power, and it's done. So 15x minus 9x is 6x, and plus 4. To further simplify, you can still remove a 2 and multiply by 21 if you want to do that. I would like to do that. 42x squared, 3x plus 2. I factor out a 2 from 6 and 4, and 4 minus 9x to the 6th.
Wait, where did 42 come from?
Because I pulled out the 2. 2 times 21 is 42.
Oh,
And I have 3x minus plus 2 in parentheses. Okay, now my turn to choose. They shouldn't, in this book, they should not be so involving, but they're also. Okay, let's look at 30. And you can choose the next one if you want. So 30 is on 164. So g of x equals the cube root of x to the 5th plus 6x. The same thing, we're asked to find the rate of change of this function at any point where the function is what?
differentiable.
Awesome, thank you. Every point where the function is differentiable. Thank you. Very good. So, yes. Will I differentiate like this? No, because I don't have a formula in my head for the cube root. But I would write x to the 5th plus 6x, everything to which power?
1/3.
Excellent. This is what I want to differentiate. I will bring 1/3 in front. I will subtract 1 from the power and differentiate the inside. And leave it alone. There is nothing else I can do here. So 1/3 x to the 5th plus 6x. 1/3 minus 1, negative 2/3 times, when you're ready, please give me the inside prime. And this is it. Here you cannot do anything else.
5x.
Yes, to the 4th plus, we are a team. Yes, we're a team. You said 5x and I had to put something in. Good. I'm more interested in working with word problems than just differentiating super sophisticated functions. So let's look at business and economics, life and physical science. So anything you'd like to look at, 71 through 81. 164, 165. Sorry, Maddie, I talked at the same time. I didn't hear what you said. 76 it is. Where is it? Okay, I see it. Utility is a type of function that occurs in economics. When a consumer receives X units of a product. So I have to take notes.
That concept sucks.
So one more time, we picked 76 on page 165. X units. X number of units. Amount, okay. A certain amount of pleasure or utility, U, is derived. Utility. Fine. Suppose the utility related to the number of tickets X sold for a ride at the county fair is U of X 80. The square root 2x plus 1 over 3x plus 4. Perfect. Find the rate at which utility changes with respect to the number of tickets bought. Find the rate of change of this function with respect to x. It's not a nice function. It's an ugly function. So what do I have to determine? What am I looking for? The rate of change of u with respect to x, which means I need to find the good u prime of x. Leave 80 alone. So if I want to differentiate the square root of x, what do I write? 1 over 2, the square root of this, 2x plus 1 over 3x plus 4. I should write times x prime, but this is not a poor simple x, but it's that whole thing prime. So let's write in 2 steps. So 2x plus 1 over 3x plus 4 prime first. See, I have 80 divided by 2. So I'm going to write 40. I am dividing 1 by a fraction, even if it's under the square root. Right? So this now becomes the square root of 3x plus 4 over 2x plus 1. Now I have to differentiate this thing. Which formula or differentiation rule applies here? Quotient rule. Very good. The denominator has to be squared. Can anyone give us the numerator prime? Remember the formula. The numerator prime times the denominator minus the numerator times the denominator prime. The top prime times the denominator minus the top times the denominator prime. What is the derivative of the denominator? That's it. Yes, I have to distribute. So 40, the square root, 3x plus 4 over 2x plus 1. And yes, I have 6x plus 8 minus 6x minus 3 over 3x plus 4 squared. Do we see this? 2 times 3x, 2 times 8, negative 3 times 2x, and negative 3 times 1. Do you notice anything here? These two go away. 8 minus 3 is 5, and I can move it and multiply by 40. So this is 200 over 3x plus 4 squared times the square root 3x plus 4 over 2x plus 1. Don't look at me, Maddie chose it. Just kidding, we need to see something like that anyway. Thank you, Maddie. So 8 minus 3 was 5. 5 multiplied by the number in front, 200 over the denominator and the square root. We don't like to write anything behind the square root because we may be tempted to extend the square root on top of that. So we normally don't write anything following the radical. Okay. We can come back for more problems, but I like to illustrate with some examples with last section, higher order derivatives, which means the second derivative, the third derivative. So let's write that. Last section, higher order derivatives. And we have different ways of writing them. So the second derivative, the third derivative, the fourth derivative, and so on and so forth. Here's another way. d2y over dx2. These two are the same. Can anyone give us the next one with Leibniz notation? d3y over differentiated with respect to x 3 times. Can anyone give us the third one? d4y, the fourth derivative of y with respect to x, of course, 4 times. And we can go on forever. Choose anything you like. And I prefer a word problem on page 172. Anything you want from 1 through 60. Nineteen it is. 19, I see it. Okay. So f of x equals 19. X squared plus 3x to the 7th power. Let's see what we're asked to find. They're asking us to find f double prime of x. So they want us to find the second derivative. How do I find the second derivative? Not before finding the first derivative, exactly. So let's find f prime first. Obviously, this is the chain rule, because there is an inner function and there is an outer function. So please tell me what to write. 7, we bring down the power. We subtract 1 from the power, which is we get 6 times the inner function, which is
2x + 3.
yes. That was the first derivative. Well, of course, the second derivative will be a mess. Can anyone tell us why I claimed that the second derivative will be a mess and not the 7? The 7 will wait for us. Because this is one function multiplied by this function, we cannot distribute them. So now we have to use the product rule. This as the first and this as the second. 7 will patiently wait. Remember the formula. 1 times 2. 1 prime times 2 plus 1 times 2 prime. 1 prime, please. 6 x squared plus 3x to the 5th times, I didn't get to the second, times the inner function prime. 2x plus 3. I have to differentiate. 2x plus 3. Times 2x plus 3. Okay, I'm going to put square. Plus, I copy the first one now. And I differentiate the second one. Not too bad. The second one is the derivative of the second function will be just 2. And close the bracket. Okay, let's go back for a minute together. So the function was set blah 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 raised to power 7. We brought the power in front, we subtracted 1 from the power, and we differentiated the inside. Now this is the first function and this is the second. 7 waits outside. I differentiate the first. 6 x squared plus 3x to the 5th power times the inner function prime, which is 2x plus 3, times this, I'll put the power 2. Plus, I copy the first one times the second one prime, 2. Is this it? No, because I can factor. And you'll tell me how many terms we have in brackets and what is the common factor. So I see this and I see this. And you'll tell me what to factor out next to 7. Look everywhere and say, oh, these two have something in common. What is it? X squared plus 3x to which power? Exactly. Now open the bracket again. And please tell us what is left from the very first term once we pull out this factor. 6 is left, and 2x plus 3 is left squared. So 6 is left, and 2x plus 3 squared. Plus, what is left from the second one? The 2 is left, and from these 6, we pulled out 5 of those. So plus what? 2, and in parentheses, that's it. The final step will be to work on this. So I have 6, 2x plus 3 squared. How many terms? This was the first agreement we made this semester. When we square binomial, you would give me how many terms? 3. Excellent. Awesome. So 4x squared plus 2 times the first times the second, 12x, and plus 9. Plus 2x squared plus 6x. So final answer, 6 times 4, 24 plus 2, 26x squared. 6 times 12, 72. 72 plus 6, 78. X and 54. And this is it. Any questions so far? We have 3 more minutes. Let's look at a word problem. Anything you want. I would like you between now and Tuesday to work on this. Everything, go back to your notes, work on this diligently. Redo all your notes from class. I tend to pick problems from, thank you. I tend to pick problems from, thank you, problems we do in class. So that's your first step. So now let's choose a word problem. We still have, I think, a couple of minutes. Everything you see here was done in class in some way or another. So I would like to go over this.
Is this similar to what the test will look like?
Everything, so every class is different. So what we did in class first has to be reviewed. So when I write the test, I did not write the test yet.